afternoon. Thank you for joining us today. We are paraGraphic. My name is Elaine. My teammates are Tiffany, Lila, and Kara. paraGraphic is a visual text analysis tool that renders a 3D model of relationship between words. Drawing on machine learning and statistic analysis, paraGraphic determines the 3 ideas that make the most difference to text, and then plot each word in relationship to those ideas. We designed paraGraphic because we are interested in exploring machine learning in relation to language analysis. Here is my teammate Tiffany to walk through our app.
So a user arrives at our homepage to see a visualization that they can explore. User can view one of our samples or the 20 most recent user-generated visualizations. This sample is that we'll be loading is from a Wikipedia article about chemotherapy. And if we open up the info panel to look at the input form, we can see that the axis labels which are returned as part of our analysis are pretty reasonable as key ideas for this text. The user can rotate the model, zoom, or move the model. Each sphere represents a word in the text analyzed. When user hovers over the sphere, the word associated will be displayed on the bottom right of the screen. Our info panel toggles to reveal an input form where the information about the current model loads. To enter a text of their choosing, a user can simply copy and paste the text of their choice and add a title. And after a few seconds, the visualization will load. And now here's Layla to talk about the architecture of our app.
Thank you, Tiffany. We used React and Redux for the front end to centralize information about the state of our app. And for visualization, we use Three.js, a powerful library for 3D rendering. And Firebase provide an efficient way for us to store user-generated data and update our project page in real time. For our backend, we use our backend is written in Python in order to take advantage of some of the machine learning and statistical analysis libraries that are not available in JavaScript. So this project posed some really interesting challenges. We researched Google's Word2Vec, a natural language processor. Word2Vec using a large set of data and a machine learning algorithm, and it will determine the word vectors based on the context in which the words appear. And words that are similar, close in meanings, will have vector values that are very similar. And Kara will teach us what's the logic behind it.
Thank you. To model the complexity of language, Word2Vec generates vectors in 300 dimensions. So one challenge we faced was how to meaningfully display results in 3 dimensions. In an earlier iteration of our app, we performed a simple vector projection in relation to user-generated keywords. However, following a robust critique from someone better versed in statistical methods, we decided to refactor to use principal component analysis, or PCA. PCA reduces data from many dimensions to a few key dimensions by identifying those that contribute to the most variation in the data. These key dimensions are defined as vectors, which we can then pass back through Word2Vec in order to find the words that lie closest to them. Finally, to render our 3D graph, we create a sphere object in Three.js for each word, and we developed a color algorithm to assign a color that differs according to that word's position in relation to our keyword axes. We very much enjoyed building paraGraphic, and we hope you'll enjoy using it. You can find us at paragraphic.us. Thank you.